Welcome to the chapter 1 of gasoline engines class. Inboard, outboard, gasoline engines. We are going to start with the fundamentals of both of them. You remember that I explained in the previous class in diesel that the inboard diesel engines is basically an automotive engine adapted for marine applications. The inboard gasoline engine is exactly the same. Is an automotive engine adapted for marine applications. The adaptation is exactly the same. We are going to replace the radiator for a heat exchanger. And we are going to improve the exhaust manifold in order to avoid high temperature inside of the engine room. And also, one important thing right now in gasoline is use in the electrical parts like an alternator and a start motor, ignition protected elements and the ignition system. All the electrical parts of the engine, all the accessories should be ignition protected engine because the gases, the fumes from the gasolines are lethal, right? Yes, this is the topics that we are going to analyze, and we are going to study one per one in details. Okay, my friends, the majority of the boats, the commercial pleasure boats, pleasure yachts, the hull is a V hull, like the hull that we have on the screen right now. Those are V hulls, but the inconvenience with the V hulls is that they require a lot of energy, a lot of power to reach the cruise speed. Of course, when the boat is at cruise speed, the consumption of fuel and energy is less. Yeah, of course. But what about in between the stationary position and the cruise speed? You need to spend a lot of energy, a lot of fuel in order to reach the top cruise speed. That's the inconvenience. Okay, when you are at cruise speed, that boat is highly efficient, the V hull. The problem is reach that speed. You need a lot of energy, a lot of money in fuel. I demonstrate in previous classes that the factor that is really important in the analysis, design, construction, fabrication of boats is the thrust, the torque, because finally the torque produces thrust. And we are going to be concentrated all the time. You remember in the previous classes the procedure to calculate the turbo and the supercharger, we use both of them, horsepower and torque. But the torque is critical because with the torque I can calculate the thrust. Alright, like I explained in my books, for inboard boats, what really produce the thrust depend on factors like the type of hull, the selection of the propeller is critical, the shaft and propeller configuration, I explained in my class of Introduction to Marine Engineering, and the output torque. Other factors like the gear ratio of the transmission is critical, and the quality of the bottom of the boat, the surface, in order to avoid drag. All of those factors affect the final performance of the engine. Alright, my friends, we are going to analyze the first one, the torque and how to produce the maximum torque. Okay, in order to understand that concept, we are going to refresh quickly the different type of fuels. In the previous class, in diesel class, we study in detail the diesel. We fabricate biodiesel, you remember? We fabricate biodiesel, and we study in different countries what about the quality of the diesel. And we demonstrate in our previous class why the bad reputation of the diesel engines. This is a wrong concept. I hope right now you are clear that the diesel engines are highly efficient engines. The inconvenience with the diesel engines is not because the engine, is not because the design, is not because the cycle of the diesel engines is not efficient. No. It's because the bad quality of the fuel depending of the countries. And we analyzed, you remember in that video, what happened in different countries around the world. How is the quality in terms of amount of sulfur in the fuel? Yeah, depending on the amount of sulfurs, the fuel is considered bad fuel or good fuel. Alright, with gasoline, it's pretty similar. Remember that the gasoline is lighter in comparison with diesel. How much? Gasoline is 6.1 pounds per gallon, the weight, and diesel is 7.1 pounds per gallon. Yeah, diesel is a little heavier. And don't forget that in general terms, the diesel is in between 15 and 30% more efficient than gasoline. Yes, my friends. The diesel engines are highly efficient. Don't forget that this is very important. This is the point. If you check this curve is the torque, and this one is the horsepower. And we are going to analyze the majority of our studies, the majority of our analysis are located. You remember in the previous class the calculation of the turbo, the calculation of the motor mounts, all the calculations are related with the point where the engine is at maximum efficient. And normally that point is the point where the engine produces the maximum torque. In inboard engines, this is for inboard engines, in inboard engines, the peak torque is in this point. The peak torque is over there. This is the maximum torque in the curve, and this is the point where both curves are crossed. This is the point of high efficient, the maximum efficient. This is the point of maximum efficient, the point where the curve of the torque and the curve of the horsepower cross. And normally in inboard engines is around 1400 RPMs. Yeah, this is the point where the majority of the inboard engines produce the maximum efficient. In general terms, the majority of the marine engines are designed to run continuously at between 60 and 75% of the maximum speed. Yeah, normally those engines are running in between 60 and 70% of the maximum speed. This is they are designed to run in this point. Okay, in this slide, I want to check where is the consumption of energy in a typical boat. This is a great graphic. 35% of the energy produced for an engine is converted in heat and is dissipated on the atmosphere. This is the first point. 35%. 25% of that energy produced for the energy is converted into heat and vibration absorbed for the surrounding water. In between this and this, we have a 60%. Okay, what about the rest of the energy? In between this and this, we have drag, we have resistance. Drag in different ways. 10% is given overcome wave resistance. 6% is prop wash against the hull. 7% is overcoming skin friction. It's friction. This is like a 26%. 26% is basically drag. And in between this and this is 60%. In other words, we have around 14% of the total energy produced for the engine. Only 14% of that energy is used to produce torque. on the propeller. Wow! 86% of the energy produced for any type of engine is dissipated. In heat, in friction, in vibration, in Only between 13-14% in a good scenario is used to produce torque and thrust. A little, no? My friends, 85% of the money that you put on the fuel tank is bye-bye, and only 14% is used to produce the movement of the boat. No? A lot of money on the garbage. Yes, for that reason, in the future, you will be the engineers of the future. I want that you design highly efficient boats, highly efficient cars, highly efficient airplanes, highly efficient trains. You engineers, you are the future of the world. Depend on yours. Yes, the diesel and the gasoline engines, okay, the diesel engines are a little more efficient than the gasoline, but those engines are not fully efficient, no. A lot of energy is dissipated on the environment. Yes, probably the electricals have a better future, but you need work more in the batteries. The electrical car, the electrical boat, the electrical airplane was invented 60 or 70 years ago completely. The problem, the inconvenience of those cars, planes, trains is the batteries. Your cell phone is perfect. You have questions about your cell phone? No, your cell phone is wonderful, no? The application, nice. The cameras, the light, the music, everything is perfect. What is the only one inconvenience in your cell phone? The battery. This is the inconvenience. The rest is perfect. What is the only inconvenience of the electrical cars? The batteries. The rest is perfect. Yeah? Yes, my friend. The electrical cars, the electrical boats, the electrical planes are the future. But we need work, we need investigate, we need study, and we need discover better materials to storage energy. The inconvenience are the batteries. Of course, every day the people discover better batteries. But today we don't have the ideal battery. This is the inconvenience. Yes, my friend, you need to study more. And probably in 30 years we have eliminated the majority of the internal combustion engines, and they are replaced for other type of motors, other type of engines that produce your own energy. I don't know if the electrical is the solution in the future, but in the next coming future, probably the electrical is the future. Only 14% of the total energy produced for the engine is used to produce thrust. This is a little. It's too much energy waste on the environment, dissipated on the environment. Can we improve that equation? Yes, yes. You are the engineers, you are the futures. I hope that in the next coming years, more efficient cars, more efficient boats are coming because you design better equipment. Don't forget, the secret is in the investigation, in the research. The secret is discover elements with higher capacity to storage energy. In this moment, the electrical cars, the electrical airplane, the electrical boats are limited because the batteries, because the capacity of the batteries. This is the inconvenience in the majority of the conversions. Can I convert my boat, my actual gasoline boat, inboard or outboard, into electrical easily? Yes. Can I replace? I have an steam drive boat with an inboard outboard like this one. Can I replace that inside the inboard engine gasoline for an electric motor? Yes. I am going to explain in the next episode that procedure. The secret is I am going to replace that engine for an electric motor that produces the same or higher torque than this engine. And of course, I can replace that inboard gas or diesel engine for my new electric motor, AC or DC. If the motor produces equal or higher torque, bye-bye, I can replace. And right now I have other source of power completely different, clean. Yes? Okay, but if it's DC, I need a lot of batteries and I need too much capacity on the batteries. And we are going to study that conversion in other episode. Okay, my friends, let me check this slide. This slide is wonderful. It's about the consumption in gallons per hour of fuel. The diesel engines consume around 1 gallon per hour for every 18 horsepower used. In other words, in order to estimate the consumption of a diesel engine, you can multiply the horsepower of the engine times 0.055. In a gasoline engine, the gasoline engine needs about 1 gallon per hour per every 10 horsepower used. What is the meaning of that? In order to calculate the consumption of a gasoline engine, we are going to multiply the horsepower of the engine times 0.1. I have a good equation here. Let me multiply. Okay, suppose that I have a diesel engine, 150 horsepower. And I have a gas engine, and the same capacity in horsepower, 150 horsepower each engine. And once again, for diesel, I am going to multiply the horsepower 0.055. I am going to multiply the horsepower times 0.055 and for gasoline I am going to multiply for times 0.1. Okay, 150 times 0.055 is equal 8.25 gallons per hour. And 150 times 0.1 is 15 gallons per hour. The consumption of the gas engine in similar conditions is double practically than the consumption of the diesel. Nice. This is a perfect equation to demonstrate how much do gasoline and diesel engines consume. Good question. Don't forget those factors. 0.055 times horsepower and 0.1 times the horsepower for gas. This is for gas and this is for diesel. This is a simple equation to demonstrate that the consumption is less in similar conditions. Both of them 150 horsepower, 150 horsepower. Yeah, the consumption is less for diesel engines. Alright, my friend, this is only to keep in mind in the future, when you design boats, try to investigate if you have the hull and you are in the point where you need to take a decision what engine is more convenient. You need to analyze a lot of factors. You need to analyze what is the future use of this boat and what is the situation with the environment and how much is the money that I have for the project. And with those factors you take a decision if you install a diesel engine, if you install a gas engine, or if you install an electric motor. Let me check this this wonderful slide is checking about the displacement hold and the theoretical speed. No, this is excellent about the engine RPMs and the speed, the typical speed and the consumption in gallons per hour. If you check, of course, at higher RPMs, the consumption in gallons per hour is higher. No? This is a good equation. Only to keep in mind when you operate your boat, try to use the boat always at the peak torque, at the point where, according with the manufacturer recommendations, the engine should be running constantly. This is the point where the maximum efficiency is produced, and this is the point where the engine have less consumption or optimal consumption of fuel. All right, don't forget, this is very important. What is an engine? Is an element, is an equipment used to burn air and produce torque. Burn air and produce torque. Of course, that torque can be converted in work. Okay, my friends, and we checked in previous episode, the inboard engines are automotive engines converted into marine. I explained the procedure, and we are going to refresh again that concept. And the outboard engines, right now we are going to talk about the outboard. The outboard engines are coming in 4 strokes and 2 strokes. Especially in gasoline, there are a lot of manufacturers that today they fabricate outboard engines in 2 strokes. Those engines are highly efficient because those engines produce better torque, high torque than the 4-stroke engines. Those engines have inconvenience related with the noise, related with the pollution, but the new designs, Evinrude have an excellent design that with the low pollution, low level of contamination, those engines are fuel injected, electronically controlled, and the fuel economy is excellent, and the level of noise is too low, and the efficiency is high efficient. All right, my friend, I am going to refresh quickly the basic components of a typical outboard engines. We have on top the power unit. The power unit is could be 2 strokes or 4 strokes. The middle section is the section where the gases are controlled, especially the exhaust gases. And the lower unit in the bottom is basically the transmission. Is the gear case, the gearbox, or transmission. We have a 3 element: the power head, the middle section, and the lower unit. Those 3 sections are the components of the outboard, and we are going to study each of those components in this class and the next coming class, transmissions. All right, the power head on top can be 4-stroke, 2 strokes, or electrical. Yes, you can remove that engine and you can replace the engine for an electric motor, AC motor or DC motor. This is the class of hybrid engines. This is the process to convert those outboards into hybrid or full electrics. Okay, right now we are going to refresh quickly the concept about the 2-stroke engines. All right, 2-stroke engine is a combustion engine that completes the cycle in 2 movements of the pistons, in comparison with the 4 movement of the piston of 4 strokes. You remember, in 4 strokes, during the intake, the piston goes down, 1 movement. During the compression, the piston goes up, 2nd movement. During the power, piston once again goes down, 3rd movement. And during the exhaust, piston once again goes up, 4th movement. 1, 2, 3, 4 movements to complete 1 cycle, to complete the cycle of intake, compression, power, and exhaust. Oh, in those 4 movements, the crankshaft rotates 2 times. This is for 4-stroke engines. In 2-stroke engines, when the piston is going down, occur intake and exhaust at the same time. And when the piston is going up, occur power and exhaust, power and compression. Yeah, 2 strokes in each movement. For that reason, the name of that process is a 2-stroke engines. All right now I am going to explain quickly what is the main difference between both type of engines. But in order to understand easily the 2-stroke gasoline and 4 strokes, let me explain something about that. If you remember, in a 4-stroke gasoline engine, we have the head, and in each side of the head you have a exhaust manifold and intake manifold. This is the intake manifold. And on the intake manifold, you have the throttle body or carburetor, and on top you have the air filter. That's the air filter. This is for 4-stroke gasoline engines, or diesel is similar. All right. For 2 strokes, and remember, in 4-stroke you have the valves located on the head, the intake and the exhaust valves located on the head. And the camshaft is connected with the crankshaft by means of the timing chain. Right? This is in 4 strokes. In 2 strokes, what happened in 2 strokes? In 2 strokes, there are some difference. For example, in 2 strokes, the cylinder is not a cylindrical element like this. The cylinder have a couple of holes, one in each side, 2 holes, one in front of the other one, like the picture that you have on the screen right now. In the bottom of the cylinder, if you check in the picture, there are 2 holes, one practically in front of the other one. And additionally, the shape of the piston, the head of the piston in 2-stroke engines have this shape, like a castle, like this. And what is the idea? In the bottom of the cylinder, there are the holes, one hole here and other hole in the other side for exhaust, because the exhaust manifold is located here in the other side for exhaust. Yeah, one of the difference, if you check for visual inspection, the 2-stroke engines have the input of the mixture and the output of the gases in the bottom of the block, not on top. In a 4-stroke engines, the intake and the exhaust manifolds are located on the head, in each side of the head, like the picture that you have on the screen right now. This is in 4-stroke. In 2-stroke is in the bottom of the block, because in this particular case, this is the intake manifold. And in the intake manifold, you have here the carburetor or throttle body, and the carburetor mixed the fuel and mixed the oil and mixed the air. You have fuel plus oil plus air entering in the combustion chamber in the bottom. Yeah, for one side of the holes. In the other side, you have the exhaust. Let me show to you. This is the situation, exactly the situation. This is the block, and this is the head. The head only have the hole for the spark plug. Yeah, and on the cylinder you have one hole here for intake, and you have other hole here for exhaust. Let me check what happened. And in the bottom, in the crankcase, when you talk about the 2-cycle cylinders or 2-stroke engines, the name of the oil pump is the crankcase. The crankcase and the block, this is the bottom of the engine. In the bottom of the engine, in the crankcase, this is the crankcase, In the bottom of the crankcase is where the oil pan is together with the block. There are one port with a valve, like a check valve. Right now, I am going to explain how the reed valves work, where are located. In this moment, this is a two-stroke engine, 4 cylinders. Remember, the engine in outboards two-stroke is located on top, on the power head, like the video that you have on top of the screen in this moment. Yes, the engine is located vertical. In other words, this air filter located over there is in one side of the engine. Yeah, and we are going to remove the air filter in this moment, and immediately those are exactly, this is the intake manifold, and those are the throttle bodies. The intake manifold and the throttle body is integrated. And where is located? In the crankcase. Yes, we are going to remove right now the intake manifold with the throttle body, and we are going to see the reed valves, and after that we are going to remove the bracket of the reed valves, and we are going to see the connecting rods, of course, and the pistons. Yes, we are located in the bottom of the engine. Because the engine is located vertical, it's on the side. It's clear? All right. This is the bottom. This is the bottom of the engine. This is the crankcase. Okay, we are going to remove in this moment the manifold, exactly, the air filter. I remove the air filter, and we have access to the manifold. Those are the flaps or throttle body. Look at this. This is the throttle, the TBI. This is the throttle position sensor. The throttle position sensor controls the position of the flaps in order to control the air coming into the intake manifold. Yeah, this is the throttle position sensor. Okay. Throttle position sensor controls the movement of the flaps and speak with the computer. And this is the crankshaft position sensor. This is the crankshaft position sensor because the flywheel is located here. Yeah, this is the crankshaft position sensor, and the crankshaft is in front of the teeth on the flywheel. Yeah, those are the flaps connected with the throttle position sensor. Correct. The air enter over there on the intake. Yeah, this is the flywheel. Yeah, the flywheel. The crankshaft position sensor in front of those elements. Because you remember the crankshaft position sensor work with a magnetic signal. If you have the separation of those teeth equal, and suddenly you have in between two of them one element in between, this is the zero position. This is the zero position. Right now I am going to explain. This is the zero position. Yes, this is the flywheel. And inside of the flywheel, we have a coil that generates power. I'm going to explain later in other episode. That coil produces AC power. After that, that AC power is rectified into DC and is used for the harness for the rest of the sensor. Yes, this is the position for zero position. Yes, that's the flywheel in front of the crankshaft sensor, and of course, it's located at the end of the crankshaft. The end of the crankshaft. Yes, the other end of the crankshaft is in the bottom of the engine. You can see in the video that we have on the left of your computer. Exactly, that's the seal. That's the seal that it is leaking. You have oil coming out in the middle section, and you have oil going out through the exhaust pipe. And the exhaust is going into the middle of the propeller in outboards. Yes, my friend, this is the seal. This is the back seal. Of course, here we have another seal. We have another seal here, the top seal. All right, this is the crankshaft, and this is the position for zero position. Exactly, that one. That one is aligned for the top, the center for the zero position. I'm going to explain later. Exactly, that one is aligned for zero position. In this moment, you have on the top left screen the zero position, And we have the marks for advance and the marks for retard. Correct. Those are the marks. Exactly. Okay, that's the flywheel. And now we are going to remove the intake. Exactly. Look, those are the marks. Those are the marks. Those are the marks for 0. And you advance in one direction or retard in the other direction. Exactly. Exactly. This is the position for the flywheel. We are going to explain later that movement according with the timing. Okay, my friend. Now we are going to remove the manifold. We are going to remove those balls quickly. Exactly. Those are the balls for the intake manifold integrated with the TBI, with the throttle body. The throttle body allows the intrusion of air. Let me explain something, my friends. This is the intake manifold with TBI integrated. In this particular example, in this engine, because this engine is direct fuel injection, in this manifold, you allow the input of air. You allow the input of air and the oil enter in other small hoses in the crankcase coming from the oil pump. The oil pump suctions the oil to strokes from a separate reservoir. In other words, when we remove this manifold, we have the oil and air mixed. The fuel enters directly in the combustion chamber because this engine is direct fuel injection and the injectors are located on top, on the head, and the head is in the opposite side. All right, my friends. Right now, we are going to remove the manifold. The manifold is ready to be removed. Correct. All right, that's the manifold. Look, this is the intrusion of air. Let me show to yours better. Perfect. Exactly. This is air, 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 and oil, oil here. In other words, in this point, we have air mixed with oil. Wonderful. Correct. Correct. Perfect. This is the manifold, and the manifold is in the bottom. In the bottom. This is the crankcase, my friend. This is the crankcase. And now we have access to the reed valves. Perfect. We are going to remove those reed valves carefully. This is the bracket. This is the bracket where all the reed valves are located. Okay, we are going to remove quickly. This is the bracket, and yes, this is the crankcase. This is the crankcase. After the reed valves, we have access to the connecting rods of each piston. Yeah, we are located in the bottom or crankcase of the engine. Yeah, we have a problem with one of the bolts, but with Professor Rodriguez, we are removing the bracket for the reed valves. The bracket, exactly. Those are the reed valves, correct. And over there, we are going to check later, are the connecting rods. Those are the reed valves or check valves, because if the air is moving in this direction, right now we are going to explain, if the mixture is trying to return, those flappers close and avoid that the mixture return outside. Only allow in one direction. Right now, in the next part of this episode, I am going to explain how those reed valves or check valves or flappers works. All right, and this is correct, and this is the other part where the connecting rods are located. We are going to focus with the camera over there, and we are going to check that the connecting rods are here. Look, exactly. You remember in our previous class, those are the connecting rods. This is the bottom of the engine. Yes, my friends. Yes, those connecting rods, they have special bearings. The bearing that you have in the top left of your screen right now. Those bearings are not plain bearings, are needle bearings. Exactly. Those are the bearings, and we are going to study those bearings later. Those bearings receive the oil here in the crankcase. The oil enter over there and lubricate those bearings. All right, my friends. Yeah, this is the crankcase, and the bearings are roller bearings or needle bearings. Okay. And now we are going to analyze, yes, this is the movement of the crankshaft. This is the movement of the crankshaft. Exactly. This is a better view related with the movement of the crank pins. Yes, my friends, the throttle body, the intake manifold is located in the bottom, exactly. And the reed valves are located over there. One group of reed valves like this per each cylinder, per each piston, exactly. Allow in one direction the air, and the air enter over there, perfect, enter, and avoid in the other direction. In the other direction, close and avoid the movement in the opposite direction. Danny, what is the function of the reed valves, and how can you check if those elements are working properly?
Okay, the function of the reed valves is it goes into the intake, okay? And when you have the intake, when you have the compression stroke, it closes these valves, and when you're going on the suction side, the reed valves open to allow fuel in.
Like a check, like a diode, no?
Yeah, kind of like a diode, one way.
In this direction, open,
Right.
because those flaps open over there, and the fuel enter.
Right.
Enter over there, and in this direction, close.
It closes.
Oh, perfect.
So only that way, if you didn't have that closed, what happens is the compressor will come out.
Of low compression.
Yeah, and then a symptom of a bad reed valve would you would see air and fuel spitting out of the intake.
That's the symptom. That's the symptom, and you have low compression.
And low compression.
And what is the enemy of those elements?
The enemy is any debris coming in here and water.
And water. It's damaged because this element is.
They start corroding.
Oh,
and
it's
it won't seal
corroded.
properly.
It's a special stainless steel,
Right.
no?
Yeah, it's a stainless steel specifically made for that. That it actually opens and closes without breaking.
And it's supposed to that sit properly on the plastic, no?
Correct, just like that side.
Perfect. All right, nice. And is possible replace only the flaps?
Yes, you can.
You order the kit and you replace that.
Yes. Now, if you wanted to check if you had bad reed valves and you wanted to take it out, what you would do is you would put this in the light. See, there's no light right now, right?
Perfect. No lights. What about this one?
Slightly, you would see air. You know the reed valves are bad.
Perfect. Danny, in other words, I have one per each cylinder.
Correct.
Correct. And if I have low compression in one particular cylinder, this is the possibility.
It could be one of the possibilities.
One of the possibilities.
Yes.
The other one could be on the head or
The head, the rings, the piston.
pistons. Okay, but this is one of the possibilities.
Yes.
All right. The enemy is the water.
The water is absolutely in any debris. Like if there's a catastrophic failure, usually metal come out, it'll damage reed valve. Anytime you have a catastrophic failure in a cylinder, you have to replace the reed valves. We don't even rebuild them; we just replace it with a brand new.
Correct.